S8711A UXM 5G test application. Verify 5G NR chipsets and devices throughout the development workflow. Around the world, commercial deployment of 5G fifth generation technology is accelerating to address the wide range of existing use cases for customers and industry verticals. Enabling 5G deployment requires rolling out a new chiplet and devices at the right prices and time. Most recently, non-terrestrial network (NTN) reduced capability RADCAP and 1024 QAM quadrature amplitude modulation in the downlink DL introduced new challenges for efficient testing of 5G devices used in large variety of the applications. Keysight addresses these 5G design challenges by delivering a new comprehensive range of solutions and services that span the device workflow and accelerate innovation for next-generation devices. The Keysight S8711A 7811A UXM 5G test application is a scalable solution that span the development and acceptance stages of a 5G device workflow. The solution provides a high level of customization for network parameters and testing scenarios. Keysight first to market 5G network emulation solutions are mature and have been adopted by key 5G players. The test application, aka TA, provides the most comprehensive solution for 5G device development in the market. So Keysight, the table of contents. Table of contents characterizes the latest 5G NR device behavior, emulate a non-terrestrial network, emulate a fifth generation NR radical network, emulate a network with the latest feature, executing functional tests, analyze device RF performance, simulation two networks on a single UXM 5G wireless test platform, test additional technologies, automate test procedures, troubleshoot signaling issues, test FR2 using 5G NR beam management, accelerate 5G chiplet and device development. Learn more about Keysight solution. Characterize the latest 5G NR device behavior. The TA software configures and controls the Keysight UXM 5G wireless test platform emulating a 5th generation U radio NR network figure 1. The solution spans the development and acceptance stage of the chipset and device workflow, from early prototype testing to integration and verification. It offers significant configuration and customization capability for research and development R&D purposes. The S8711A UXM 5G test application includes a comprehensive suite of tools for network emulation, radio frequency, RF parametric testing, and functional testing, and application level testing, and the interactive and easy-to-use graphical user interface GUI handles operations related to emulation and testing across all scenarios and accelerating time to market. So feature 1 is the Keysight UXM 5G wireless test platform and the S8711A test application software. The most powerful and integrated 5G NR network emulator, easy to use, flexible to interactive testing. So the maximized lab spaces with a small footprint and support 5G NR, NTN, and RedCap and long-term evolution LTE, multi-red radio access technology, and emergency calls, eCall, and 2G and 3G, vehicle to everything, CV2X, NRV2X, and EMTC, CAT-M, and the narrowband Internet of Things, NB-IoT, and NB-NTN. Provide a full third-generation partnership project 3GPP and signaling in frequency range 1 via FR1 to 7.125 GHz and frequency range 2 FR2 baseband interface, non-signal calibration, and layer 1 testing, and eliminating the need for an external switching matrix and complex cabling with the internal RF input-output RF-IO switching for flexible and dynamic port mapping. Provide a high RF port density and scalable bandwidth for flexible band combination testing and carrier aggregation CA up to 8 TXTL and 8 receiver RX uplink UL RF ports at up to 1600 MHz bandwidth. Offer a bandwidth fading for advanced performance testing of 5G NR and LTE technologies, including NTN. Support more than 1 GB Ethernet connectivity for very high data rates. Easy to use with flexible and interactive testing. Control the UXM 5G wireless test platform with the internal personal computer PC and the touchscreen interface. Characterize the device receiver quickly by inspecting block error rate BLER and hybrid automatic repeat request HIRQ statistics reported in real time for each technology and component carrier. Run RF transmitter TX measurement according to the 3GPP and test specification, or use the full range of pathway X series measurement application capabilities to explore beyond the standards. Configure the many parameters flexibly to test RF and functional key performance indicators KPI across technologies. So the benchmark function KPI such as data rate or battery consumption under realistic conditions such as different propagation models during mobility and CA band combinations. So creating the realistic scenarios with the easy-to-use GUI sweeping over many network parameters. Automate custom scenarios using standard command for programmable instruments SCPI. Test real-world behaviors with network simulation. R&D experts teams that require high configuration and parameterization capabilities in the following organization benefit from using the TA test application. Device and chip manufacturer testing RF parameters and performing functional and regression tests during early development. Laboratories and research institutes requiring a specification configuration for network emulation, core box, over-the-air OTA, and a specific absorption rate SAR, and or electromagnetic compatibility EMC testing. Mobile network operators MNO making custom RF and functional measurement for network scenarios, easily scaling from conformance to acceptance testing. So the S8711A UXM 5G test application emulates a network in real time to verify the performance of the chipset and the devices. Figure 2. Use it in the lab by interacting with a touchscreen of the UXM 5G wireless and test platform, or access it from a remote desktop. Figure 2. TA use cases. run RF measurement, benchmark functionality KPI, edit protocol messages. So focus on device performance and characterization with network emulation and test. Network emulation, RF primarily test and functional test, and direct interactive testing, indirect testing with SCPI. The create a operational environment in minutes and conduct testing and debugging in real time so that the software generates detailed logs automatically facilitating the troubleshooting, integration, and verification. Conduct the automated test using SCIP to create an operational environment and performs complex testing campaigns such as the verification of full firmware releases. Configuration shortcuts such as full throughput testing, 3GPP reference measurement channels, and a multiple input, multiple output MIMO setting facilitate development. So the TA is the most cost-effective tools on the market for performing 5G and RF and functional tests with network emulation. Ready for future. Complete network emulation for NTN with NB IoT and 5G, LTE, 5G FR1, FR2, and eRedCap, and the non-standalone NSA, and standalone SA, and TDD, time division duplex, and FDD, frequency division duplex, CV2X and NRV2X, and dynamic port mapping up to 1600 MHz per port, and interactive testing, high level of parameter configurability, and easy to use with quick configuration tools. Scalable solution scales from development to acceptance stage of the workflow and create network emulation solutions by activating software test packaging licenses. Optimize test with scalable hardware. Keysight has the optimal hardware configuration for 5G NR use cases through 3GPP release 17 R17. For 5G NRFRSA or NSA testing, test TA software is embedded in the UXM 5G wireless test platform or installed in the external test system PC connected to the platform. Add more UXM 5G wireless test platform to increase system capability and test additional component carriers if desired. So devices that support wave, millimeter wave frequencies are complex and have integrated antenna arrays requiring OTA testing. To address these challenges, the test configuration includes a UXM 5G wireless test platform provided networking emulation. So a common interface unit, CIU, and at least two remote radio heads, RRH, to convert between intermediate and millimeter wave frequencies, figure 3. So connect up to the 8 RRH to a CIU or use a CIU without a RRH to generate 6 to 12 GHz for intermediate frequency IF testing. Figure 3, 3G NR FR2 millimeter wave test configuration. FR1 to 7.125 GHz, added FR2 millimeter wave to 49 GHz and OTA. Emulate on non-terrestrial network. As the 5G network rollouts continue globally, the drive for subscribers in unserved and underserved locales and applications such as the IoT draws attention to a new opportunity. The non-terrestrial network NTN terrestrial 5G network installation feature the familiar antenna towers mounted on the ground or atop buildings. NTN installation breaks signaling away from the terrain limits using spaceborne and airborne platform projecting 5G coverage over previously hard to reach. Too hazardous to set up or economically unfeasible to service location safely. 5G NTNs provide economies of scale for operators by superseding proprietary network and delivering consistent user experiences for subscribers regardless of the mechanics of the generating devices services. So 5G NTN technology is guided by working groups within 3GPP with elements defined in R17 current and release 18 R18 depending on their 5G specifications. 5G NTN is bringing together the traditional space and satellite industry and cellular network. Figure 4. So NTN services are divided in three main categories. Proprietary satellite networks, 3GPP, 5G, NTN, which covers both NB, IoT, and NR over NTN. So unmodified cell phone, direct-to-device NTN access. The proprietary satellite networks require dedicated user terminals which are built to connect their infrastructure. The 3GPP 5G NTN standard requires modification for both network and devices, but supports both narrowband and wideband services, namely NT, narrowband, IoT NTN, and NR NTN. Unmodified cell phone access aims to provide satellite service for any existing LTE or 5G phone by modifying the network to make the satellite resemble as a regular terrestrial cell. Figure 4. Integration of terrestrial and non-terrestrial network. The incentives are high for solving system-level complexity and detailed engineering challenges, considering many potential use cases for 5G NTNs such as additional coverage in remote areas and edges of networks, logistics in transit tracking for long-haul routes and railway lines and maritime shipping lanes, and industrial application for oil field mines and offshore performance and climate monitoring stations, commercial services for airline, high-speed rail, or shipboard passengers, or vast rural areas too sparsely populated for economical tower operation. Restoring coverage in disaster areas suffering widespread infrastructure outages. Virtual simulation and end-to-end emulation test solutions are crucial for overcoming NTN deployment challenges, including providing consistently high data rates demanded by handheld and vehicle-based devices using video and mapping services, and establishing many reliable connections when needed for IoT devices. So Keysight solutions address these challenges. NTN test solutions are based on the TA, where NTN scaling works seamlessly with 5G or NB IoT signaling to emulate the complete network. Test C IoT devices designed to operate with NTN. The test application used with the UXM 5G platform emulates the terrestrial and non-terrestrial network to communicate with the device using NB-IoT and NTN signaling as defined by 3GPP and delay, Doppler, and phasing They emulate the satellite link with the test software to characterize a device transmitter and receiver RF and functional performance under verifying conditions. Data throughput, connections, stability, battery life, signal quality, and RF sensitivity are examples of device behavior that is typically tested. Figure 5 shows a TA configuration for orbit emulation. Orbit. Figure 5, example of NB, IoT, NTN orbit emulation. NTN's SIB signaling. Static delay GEO. Verifying delay and dropper GSO and NGSO. The test 5G NR devices designed to operate with NTN. Just as with NB-IoT, delay droppers and fading emulate satellite links within the TA to characterize 5G NR devices under verifying their conditions, analyzing performance in new frequency bands and mobility scenarios as defined by 3GPP, including terrestrial network (TN) to NTN non-terrestrial and network handover. Import real satellite orbit data and configure up to 4 NTN cells for mobility testing. Emulate 5G, NRTN, and NTN, and to end Figure 6. Figure 6 examples end-to-end test configuration for NTN. NTN cell icon. Internal orbit emulation files. SIB 19 settings configuration overwriting ASN loaded. Orbit channel emulation, internal UXM or simulated prop sim, and ephemeris typed by the position and velocity or orbiter. Information about the orbit emulation. Next is emulate a 5G NR RedCap network. RedCap is a new feature defined in 3GPP R17 and further enhanced in R18 as eRedCap. RedCap defines a new type of 5G NR device that have fewer capabilities, thus making it ideal for smaller, lower-cost devices that especially benefit from the longer battery life, such as those used for surveillance in smart homes and wearables. Key site E75715R UXM 5G wireless test platform and S8711A test application are in the first solution to supporting test or RedCap devices, while the original E7515B platform also supports RedCap. The E7515R was specifically designed to test RedCap and IoT devices. Configure a RedCap cell using TDD or FDD, half duplex, send and receive RedCap messages and verify functional and RF performance of RedCap devices with the TA, Figure 7. Figure 7, RedCap devices testing with the TA. Next is emulate a network with the latest features. Key site S8711A UXM 5G test application provides essential cell and connection settings required for a network emulator. Parameters for R&D customization and control beyond the 3GPP test standards are also available. Configure the desired network in just a few taps or clicks. Figure 8. 1. Aggregate cells from CAHO handovers, menu, primary, and aggregated cells are displayed. Configure, cell, settings, Figure 9 and Figure 10 with switch on the cell to transmit and a switch on the device. Figure A, TA, system configuration screen. And 3, monitoring the progress of the test and modifying parameters with a powerful GUI and SCPI as shown in Figure 9 and Figure 10. Figure 9, power and frequency for each cell. Figure 10, scheduling map for the selected cell. The 3GPP continues to develop and approve enhancement for 5G NR and release R16 and R17 features are mostly implemented. Some are in development, and R18 features are just starting. Key site solutions are aligned with the latest enhancement from the 3GPP and verify R16 and R17 and R18 features in these categories. NTN, both MBNTN and NRNTN, eradicate 5G NR FR1 DL 1024 QAM and UE usual equipment power saving. Small data transmission SDD. Coverage enhancements such as repetitions and demeration, reference signals, DMRS, bonding, conditional handover, CHO, and lower layer triggered mobility, LTM. Execute functional tests. The verifying the RF performance of a new design is important, but so is ensuring the end user experience is exceptional. Use the TA to perform functional testing of throughput and voice and video connections under many conditions to increase confidence in device behavior and performance. Validate throughput under faded conditions. Key site S8711A UXM 3G test application provides extensive analysis and statistics to test UE receiver to their maximum possible throughput. Test the following scenarios. Benchmark 5G NR IP Internet Protocol data throughput performance in fully automated environment. Verify end-to-end receiver performance for different modulation coding schemes, MCS, and resource block RB allocation. Achieve sustained maximum data rate for most common transport protocols such as File Transfer Protocol FTP and Transmission Control Protocol TCP and User Datagram Protocol UDP and PIN. Connected to the internet to test over-the-top OTT applications. Using quick config tools to schedule through output the challenging device performance. Modifying the setting to the C impacted the result during data throughput testing Figure 11. Activated multiple fading channels to simulate the real device receive conditions, selecting from multiple 5G NR baseband fading model packages for FR1 and FR2 Figure 12. Figure 1, throughput graph example. Figure 12, baseband fading channel model configuration. View all information in report and analyze data with the KeySight Log Viewer, software that is common to all network emulation solutions. For even more detailed RF and signaling analysis, use KeySight Wave Judge Wireless Analyzer. Establish voice and video connections with IMS. Testing the functionality and performance of a wireless device is essential to achieving to a good end-user experience. The S8711A UXM 5G test application includes an integrated IMS internal protocol multimedia subsystem server for that purpose. It tests UE voice, video, and SMS short message service connections operating over an IMS core. A full client and server implementation performs end-to-end functional testing. IMS is easy to configure from the IMS tab of TA software. It provides an OTA network connection between the UE and the IMS SIP, Session Initiation Protocol, infrastructure emulating a range of a network condition to verify UE performance in a controlled environment. So, autonomous configuration of the data radio bearer DRB and the packet data network PDN. Direct access to most common actions, capability for multiple clients, and voice video over LTE, VoLTE, VILTE, for LTE and 5G, NR NSA network, and voice and video over NR, VONR, and VINR for 5G NR networks. IP impairment for device voice connection, simulate packet loss, jitter, or delay. Figure 13. Figure 13. Add IP impairment to voice packets. Impairment. The verifying mobility scenarios for 5G NR. A handover changes the basic parameters of a cell while in a connected state. Handover testing ensures that a UE delivers the best quality of service under real network condition. The S7811A UXM 5G test application sweeps quickly across all channels supported by the UE without a drop in the connection. Perform SA-to-SA mobility scenarios based on a radio resource control RRC event figure 14. Exercise release 16. Conditional handover CHO mobility event between NTN and 5G NR. Verify voice and video call handovers between NR, VONR, VINR, and LTE, VOLT, VILT. Capture OTA protocol and data throughput to see the next data exchange in real time with a full message decode, providing a realistic view of how handoff between cells affect data transfer. Log, store, retrieve, and analyze previously captured messages logs to troubleshoot handovers and ensure uninterrupted service even when crossing cell boundaries. Perform handover testing in many scenarios such as NRNTN, LTE, 5G NR-NSA, 5G NR-SA, and inter-RAT. So modify the primary component carrier PCC easily from the all-inclusive display. Figure 14, 5G NR SA-to-SA mobility scenarios based on a RRC event. Event A1, serving a cell higher better than a threshold level. A2, serving a cell lower worse than a threshold level. A3, neighbor cell higher than a serving cell. A4, neighbor cell higher than a threshold level. A5, serving cell lower than a threshold level and neighbor cell higher than a threshold level 2. There is A1, A2, A3, A4, A5. Use link adaptation to evaluate device behavior. On a live network, the DL and the UL, downlink, uplink, are continuously adapting to network conditions to provide the best possible user experience. Verifying a device behaves as expected during such link adaptations minimizes the risk of the issues at the end user. Use the TA software to create link adaptation scenarios. 5G NR, BLER-based link adaptation in the DL and UL. 5G NR downlink adaptation based on PMI, pre-coding matrix indicator, and RI rank indicator, or BLER. 5G NR and LT downlink adaptation based on CQI, channel quality indicator behavior. Perform deep protocol analysis. The S8711A UXM 5G test application provides full protocol flexibility on the 5G NR cell reconfiguration messages via the ASN abstract syntax notation message editor. Use your custom RRC reconfiguration messages, seed and override the settings in the GUI to exploit simple parameterization capabilities. PDU, Packet Data Unit, editor, is a modern and easy to use. Modify ASN.1 messages directly within a direct XML extensible markup language. Sweep by the settings in the GUI using a customized ASN seed as a template. Create and edit customized protocol messages. Tune RRC settings to enable interoperability at early stages of Figure 15. Access information elements not exposed by the TA software. Send modified reconfiguration messages on the live connection. Figure 15, modifying the 5G NR RRC reconfiguration using the PDU editor. Analyze device RF performance. Verifying RF performance of the wireless devices reduces the failures in the end user and ensures that poorly performing hardware is reworked before shipment. Perform RF parametric test. The S8711A UXM 5G application integrates with the Keysight Pathway X series management applications to provide consistent and familiar results across many hardware platforms. Figure 16. Figure 16, TX measurement with Pathway X series measurement application. Use these RF measurements to test the transmitter of or UL of the UE based on the 3GPP test specification TS 36.521 and 38.521. View codes sooner with the faster IQ data captures implemented with 64-bit drivers. Increase productivity by running 5G NR and LTE measurements simultaneously. Select which 5G NR and LTE cells to measure, protocol, and analyze the parameters are fully synchronized for 5G NR and LTE. View 5G NR and LTE results simultaneously to compare or use a single measurement for more in-depth analysis. Use the Quick Config tool to configure the test channel frequency automatically according to the 3GPP TS 38.501-1. The TA software automatically sets other parameters including the absolute RF channel number, RF FCN, and offset to the carrier. Use the Quick Config tool for reference measurement channels RMC, automatically starting the channel configuration when running TX-RX test defined by 3GPP TS38.521. The TA software automatically adjusts the corresponding parameters and scheduling and time domain resource allocation, RA tables, and TDD, UL, DL configuration. Customize the band or channel to analyze the UE performance beyond the 3GPP limits using user-defined bands, number of RB starts, modulation and coding schemes, MCS, or the DL control information, DCI type. Also, test the 5G and RX sensitivity with diversity. Calibrate chipsets and devices. Boost confidence in product quality with accurate terminal calibration. The S8711A UXM 5G test application provides a non-signaling capability for chipset calibration. Save time when transitioning a new device to manufacturing by providing the same accuracy and repeatability in the lab as on the production floor. Key-side solution provide many advantages. Only wireless test solutions with both RF and high data rate test to evaluate real-world behavior. Industry most accurate, repeatable, and standard complement RF measurement. Return to the original factory performance and accuracy. Low power, low measurement uncertainties. Test efficiently over many band combinations. Verifying performance across all frequency bands supported by a device is one of the biggest test challenges. If done sequentially, this type of testing requires weeks, perhaps months. Testing across more than one band at a time is more efficient and is essential to reduce the cost of test. Keysight UXM5 Advanced has been enhanced to test across more band combinations with a single platform. Create an efficient and customizable solution for automated device verification across the band combination by adding the TA and S8711A RF automation toolset, RFA to the UXM 5 Advanced Platform, Figure 17 and Figure 18. Figure 17, RFA example of band combo test mode. Figure 18, example band combo configuration. Simulate two networks on a single UXM 5G wireless test platform. The S8711A UXM 5G application can be scaled on your instrument to simulate two separate networks to perform RF, functional, and end-to-end testing. By upgrading software only, run two instances of TA sharing the resources of a single UXM 5G wireless test platform. It reduces rep preprint, saves the cost and energy, and reduces test time and setup complexity. Perform functional tests on dual SIM UE. Characterize the behavior of dual SIM, dual standby, DSDS, and dual SIM, dual active, DSDA UEs with 4G LTE and 5G NR technologies. Verify the network authentication for each SIM SIM. Measure the power consumption as the voice calls and verify throughput for each SIM. And a performance cell lead selections between the SIM analyze messaging with a single log for both SIMs. The figure 19 dual SIM SIM U is tested with one UXM 5G. Perform RF and functional test on two UEs simultaneously. Test two UEs simultaneously, verifying UE, transmitter, and receiver RF performance, measure power consumption, establish voice and video calls and verify throughput for each UE. Use the built-in IMS for voice and video calls over LTE and 5G NR. For IoT devices, Dual TA also supports MB-IoT and MB-NTN technologies. Figure 20. RF performance of two UAs verified with one UXM 5G. Figure 21. Functional tests performed on two UEs with one UXM 5G. Connect two devices end-to-end. Emulate the real-world conditions with an end-to-end connection between the UEs. Verify latency and round-trip times more accurately. Use the built IMS for voice and video calls over LTE and 5G NR, verifying through the for both UEs. Figure 12.22. Two UEs connected end-to-end with one UXM 5G. Test additional technologies. Many devices support more than a 5G NR and LTE. Automotive devices for communication between the vehicles and infrastructure, such as emergency responder, typically about support 2G, 3G, LTE, 5G, NR, and PC5 signaling. Devices for IoT, such as doorbell cameras, appliances, and vending machines, use other technologies, such as MB-IoT or eMPC, in addition to the cellular. Verifying additional technologies with the same TA software is for 5G NR. Establish and maintain a 3G E-core, figure 23, and verify IoT devices performed with the MB-IoT or enhanced machine type communication, eMTC, category M1. And test automotive devices with a PC5 side link with C V2X figure 1224 or NR V2X figure 25. Figure 23 is a 3G cell for E-cell. Figure 24 is a PC5 side link. Figure 25 is NR V2X side link. Automated test procedures. Each operation performed by the TA software has assigned SCIP, which can occur optional displayed on a GUI. For example, modifying a trend fading a channel generates a SCPI command that is displayed at the bottom of the screen. Figure 26. It's easy to create an operational environment with automated testing campaign. Figure 26. Bandspend fading SCIP display enables. Alternative T-site automation toolsets provide quick development of automated tests. Program RF-based tests based on a 3GPP standard and using the S8711A RF automation toolset RFA combined with a TA. Similarly, the S8711A functional KPI toolset FKPI provides automation for functional tests such as power consumption, throughput, and mobility. Troubleshoot signaling issues. The 8711 UXM 5G test application generates test activity for each executed test, as well as the diagnostic data saved to log files. View and analyze the data during or after test execution. The log viewer is a user-friendly GUI that displayed several windows at once, as common across all T-site network emulation source solutions. View layers and test information of interest with filtering. Use any the default filters or create customized filters. Bookmarks facilitate troubleshoot by enabling viewing of any record in the log, figure 27. The bookmarks tab displayed all created bookmarks. The log viewer loads the following code: 5G NR and LTE protocol messages for all protocol layers, PHY, physical layers, MAC, medium access control, RLC, radio, link control, PC, PDCP, packet data convergence protocol, and RRC. So all data information transmitted and received at air interface, recorded at the MAC, MAC, PHY, PHY boundary. The control information such as activation or deactivation or physical and transport channels. Field 27. Debugging with the log viewer. Alternatively, Keysight WaveGem wireless analyzer provides in-depth RF and signaling analysis, troubleshoot challenging issues, and the latest technology include 5G and NTN. Figure 28. Figure 28. Troubleshooting NTN signaling with WaveJudge UXM 5G Plus S8711A TA WJ5900A WaveJudge hardware FS16 prop sim. Test FR2 using 5G NR beam management. 5G NR FR2 requirement on OTA test environment figure 29, representing a measure changing from the previous cabled test methodologies. The S8711A UXM 5G test application fully tests the beam management performance of a device figure 30. Characterize the millimeter wave beam acquisition, tracking, and management. Emulate signals as they reach the UE. Evaluate the scenarios. Synchronization signal block SSB detection, beam acquisition, beam reporting and switching. Figure 29, 5G NR beam management test configuration. The beam management menu defines the beams. Choose SSB, NZP, CIS, CSI, RS, non-zero, power, channel, status information root sequence, or GP, zero power, CSI, RS beam. Select whether to transmit beam ID. Map each beam to a specific angle of arrival, AOA, and power level of the UE to report different reference signal received power, RSP, RSRP values. Manually trigger the beam switch via RRC, and MAC CE control elements based on the UE reports. Use the quick config tab to configure multiple parameters for beam resources. Figure 30. Flexible beam management configuration. Accelerate 5G chipset and device development. 5G network open. 5th generation network. 5G open doors to new business models and provide an edge for those who seize the opportunity. Keysight has designed the UXM 5G wireless test platform to support a comprehensive portfolio of network emulation solutions, helping 5G NR chipset and device makers accelerate the development of workflow. From initial design to acceptance and increased confidence in hitting the largest target performance before market launch. The S8711A UXM 5G test application configures and controls Keysight UXM 5G wireless test platform. Customizing configuration for R&D test with a comprehensive suite of tools for network emulation, RF pragmatic testing, and functional and application level testing, regular release and add capabilities as defined by 3GPP with R16 and R17 functionality, such as RedCap and NTN covered today. Learn more about the Keysight solutions. To learn more about Keysight solutions, network emulation solutions, visit here at the S8711A UXM 5G test application, 5G network emulation solutions, S8702A RF automation toolset, S7803A functional KPI toolset, WJ59000A wireless analyzer platform. To learn more about the 5G challenges and solutions, visit 5G chipset manufacturers, 5G device manufacturers, and 5G service providers. Okay, thank you for your time. Thank you for your time. So, see you next time. Oh, is it quite many? Okay. Today I read S7811A UXM 5G test application technical overview. Thank you for your time. See you next time.